In this video, we will try to explain the behavior of some circuit components with the help of this DC connectivity tester. We will explain how this DC tester works. This DC tester has got a battery inside this. This has got two probes, and one probe is connected to LED. If a circuit component is healthy or a wire is without a cut in between, it glows. So we will see that when we touch these two terminals, it glows, the LED glows red. Now, when we talk of these components, this component is called as a fuse. It is a low resistance. So when a high current flows through this low resistance fuse, high amount of heat is produced through this fuse and it burns out, thereby protecting our expensive hardware. And if we have to see whether it is in working condition or not, we will just touch these probes to two terminals and we see that it glows. So the fuse is healthy. It works in both ways. That means if we reverse the probes, it works because it is resistance. Resistance behaves the same whether it is forward biased or reverse biased. Now, if we take a resistance, the resistance behaves same as that of a fuse because the fuse has got low resistance, it has somewhat high resistance. We will see it glows. So the resistance is healthy. Now, we have got a very important component of circuits, whether electrical or electronic circuits, that is a diode. The behavior of the diode is dependent upon the polarity or the biasing. We have got two types of biasing, forward biasing and reverse biasing. Forward biasing is when we connect the positive terminal of the battery to the P side of the diode and negative terminal of the battery to the N side. This is called as forward biasing. If we reverse the polarity, that is called as the reverse biasing. This diode offers very low resistance in forward biasing and very high resistance in reverse biasing. We are going to test what is the forward biasing and the reverse biasing by help of this DC tester and the diode. Now, very much important is that we have got this gray color or silver color on one side of the diode. You can see here and you can also see here. This is gray side of the diode. This gray side of the diode tells us that this terminal is N and this terminal is P. So this terminal is N, this terminal is P. We'll see that when we forward bias this diode, it works, and when we reverse bias this diode, it doesn't work. Forward biasing is when we connect positive terminal of this DC to this P side and negative terminal to N side. So this glows. So in forward bias, it offers a very low resistance. When we reverse the polarity, if we reverse the polarity, we connect positive with N side and negative with P side, we will see that the bulb doesn't glow or the LED doesn't glow. That means it doesn't work in reverse bias, or it offers very high resistance in reverse bias. We can see here, if we reverse the polarity, when we forward bias it, the bulb glows. So it works in forward bias. We can also see with another diode here, this is P side, this is N side. When we connect here, it glows. If we reverse the polarity, it doesn't glow. That means here it is reverse biased. When reverse biased, it offers very high or infinite resistance. So the behavior of this diode depends upon the polarity. The behavior of this resistance doesn't depend upon the polarity. The behavior of the fuse, which is a resistance, low resistance, doesn't depend upon the polarity. And this is another resistance. The resistance behaves same in DC circuits as well as AC circuits.